Hello everyone, good morning. My name is Sarah Marie A. Alanano, and today we will be discussing and learning about algebra. But before we continue on with the discussion, let's have a little knowledge or the terms and definitions that we will be encountering in learning about algebra. So the first term that we will be discussing is sequencing. Now, what is sequencing? Sequencing is a list of things that are in order. This is usually used in sequencing of numbers. For example, here we have 3, 5, 7, and 9. As you can see in the three dots, it means it is continuous or it is infinite. Now, this is an example or a prime example of a sequence. The next term that we'll be discussing is a term. So what is a term? A term is a number or a variable product of two or more variables of product of a number and a variable. Now, this might sound very confusing, so let's have an example of what a term is. So, as you can see here, this is an example of a term. Now, for example, in the expression 4x plus y, the two terms that are identified in the problem are 4x and y. So, that is the term 4x and y. Those are the two terms that are expressed in the problem. Next term that we will be discussing is sequencing. Now, in sequencing, there are two types, which is the infinite sequence and the finite sequence. The first sequence that we will be discussing is the infinite sequence. Now, in the infinite sequence, it states here that it is a sequence that goes on, meaning it is continuous and never ending. As you can see here in the second definition, it says that we cannot identify as to why this will end. So we cannot identify, meaning it is very continuous and it is a never-ending cycle of a sequence, meaning there will always be a continuous pattern to it. In finite sequence, it is the opposite of a infinite sequence. Why is that? Because in a finite sequence, it is the last term of the number is already specified, or we already know what the last term is. So as you can see here in the definition, the last term is known and stops at a specific number. So we already know when it stops and what the specific number is. As to an infinite sequence, the last number is still unknown and it is very continuous. In the finite sequence, it says here that the last term is already identified. Just have here an example. Yes, so here we have an example of an infinite sequence and a finite sequence. Now, in infinite sequence, there's always a dot. There's always three dots that is indicating it as a infinite sequence, meaning it is still continuing. Just for example, here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Meaning this is just a simple sequence that we use every day. So basically in counting, it is already a simple sequence, or it is already a simple sequence that we know by heart. Just like here, 20, 25, 30, 35, 40, 45, 50, 55, and so on, so forth. It is a infinite sequence. It is never ending. And here in the second example of the finite sequence, we already know that the last term that is identified is 7. So these are the first four odd numbers, and the last one is 7, meaning it is already identified and it is already stated here that 7 is the finite sequence, or the last number that is stated in the sequence. The last thing, another thing that we need to also remember in learning about algebra is the rule or the formula. So here is the rule and the formula of learning about algebra. So adding 3 to the first term to get the second term, and also adding also as same as finding the third term, which is adding 3, and also the second term. You always add 3 on the term to get the final answer, or like the second term or the third term or the fourth term, and so on and so forth. Next is arithmetic sequence. Now, what is an arithmetic sequence? Now, an arithmetic sequence is next to constant, meaning in other words, we just add on some value each time on to infinity. So it is next constant, and we add value every time until it gets bigger and bigger and bigger, and it goes on for infinity. So it is a infinite sequence. Just like here, for example. Yes, so in general, we can write arithmetic sequence like this. So it is A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, and so on and so forth. Because you can see here, there is a common difference between the two. So what is the common difference that we can identify in the given example? So we can say that A is the first term and D is the common difference. So D is the second term. So D is the difference between the two terms. So that is how we say it is an arithmetic sequence. Now, in learning or in teaching algebra, it is very important that we let the students have a very engaging activity so that they won't get bored, or they will have more knowledge that they will carry on that learning into their daily lives forever and ever and ever and ever. So they will know how to value it. So one thing that I have suggested that the students should play or like have a small activity towards it is the calendar count. Now, what is the calendar count? So the calendar count is that you are using an old calendar and then take out the pages and then mix it up in the months and the days of the week or the year, and then you're going to stack the pages to your child and assign them to organize the pages in sequential order from January to December. Now, one way for them to do this is that they do a layout on the floor. So this is a somewhat like a group activity for the students. So they'll need to figure out which month comes first and then the second, then onward until so on so forth until they finish the month. Now, an example for this activity is this one. So as you can see here, they are arranging the days and weeks of the month of March. So this is a very good example of sequencing, letting the students have a prime example of sequencing, letting them have a hands-on experience, because we are learner-centered nowadays. So it's very important they have hands-on experience with this type of learning. So with that, I am gladly going to end this discussion about the basic terms and the terms that we'll be encountering in learning algebra. Again, my name is Sarah Marie A. Alanano, and I would like to welcome the second reporter after me. Thank you very much for listening.
We will now proceed to lesson 2, which tackles the number sentence. So number sentence is made up of numbers and signs. The missing value in a number sentence can be represented by a symbol such as shape or letter. For example, a number sentence can be written like this: 8 plus 7 equals 13, 45 minus 6 equals 39, 8 times 9 equals 72, and 48 divided by 8 equals 6. So this is an example of a number sentence. What else? Can you give me some examples that can be written like this? Yes, Brittany. Okay, it can be. Another. Okay, very good. So in this example, it is not about the numbers, but it is about expressing the signs of addition, subtraction, multiplication, and division. A number sentence can also be written like this: 8 is greater than 3, 2 is less than 8, 4 is equal to 4. So this is also an example of a number sentence. So in this example, we are using the sign or the symbol greater than, less than, and the equal. What else? Can you give me some example of a number sentence that can be written like this? Yes, Sai. Okay, very good. We can also assign letters or variables to stand for the missing values in a number sentence. So here are the examples. So 7 plus n equals 12, x minus 10 equals 34, and 5 times k equals 20, and a divided by 7 is equal to 5. So what do you think is the missing number and the number 1? Yes, it is 5, because 7 plus 5 is equal to 12. How about the number 2? Okay, it is 44 because 44 minus 10 is 34. And number 3, okay, it is 4 because 5 times 4 is equal to 20. How about in the last number? Okay, it is 35 because 35 divided by 7 is equal to 5. Very good. Okay, so that's all for the lesson 2, which is the number sentence. So a number sentence can be written like those examples, how we express or how we assign the letters in a number sentence. Do you have any questions or clarifications about the number sentence? If none, then we will proceed to our activity this morning. So in this activity, I will group you into 2 groups. So this side is the group 1 and this side is the group 2. And I have a flashcards here with an equation. And I will provide you also a cardboard and a chalk, each group. So you will use the black part of the cardboard where you will write your answer to this equation. So the mechanics of this game is simple. The moment I raise the equation or these flashcards, you will start answering. And the first group who will raise their answer will get 1 point. And the group who will get many points will win the activity or the game. Is that clear to all? Okay, do you have any questions to this activity? Okay, if none, so we will now start. Ready na? Ready na? Okay, very good. So the first equation is... Okay, do you all understand what number sentence is? Very good, that's good to hear. So I hope you learned something on our discussion this morning. So that's all for the lesson 2, the number sentence. And now we will proceed to the next lesson, which is the expression and equations.
Good morning, class. Now let's move on to expression and equation. Now first is we will tackle expression. What is expression? Expression is a number or a combination of numbers and operation symbols. So expression is a mathematical phrase that uses variables, numerals, and operation symbols. An expression has no equal sign, there is no definite answer, and cannot end up displaying the value or the variables involved. Now, I have here examples. So, these examples, number 1, in word phrases and in symbols. Number 1, 3 times 10 divided by 5. So, this can be written in symbol as 3 times 10 divided by 5. Number 2 is 9 divided by 3 less 1. So, this can be written in symbol as open parenthesis 9 divided by 3 close parenthesis minus 1. Okay, do you understand that? Example, class? That's right. Now, as you observe or see in the examples, there are no equal signs and answers as well in the given symbols. So that's why it is called expression. It has only numbers, operation signs, and variable, but has no answers. Do you understand? Good job. Now let's say, for example, 10 years from now, Joey will be 9 plus 5 years old. Notice that 9 plus 5 is composed of the numbers 9 and 5, which are joined by a plus sign. So 9 plus 5 is an example of a mathematical equation. So in algebraic expression is an expression that contains one or more variables. Now, for example, how old will Joey be in H years? Now, we use variable H. Now, we can represent this as 9 plus H. we have already known that 9 plus h is an example of expression. That's right. Now, Banzon, what do you notice in this equation? That's right. This equation consists of a number a and a variable h. Good job. That's right. Good answer. So therefore, it is called algebraic expression. Do you understand? Very good. To fully understand, here are some examples of expression and algebraic expression. Okay, now let's move on to equation. Now, what is equation? Equation is made up of two expressions connected by an equal sign. So, equation is a mathematical sentence with an equal sign, which shows that two expressions on either side are equal. An equation contains equal sign. It shows answer or ends up representing the value of the variable. Now, always remember that an equation has equal sign and answer, while expression has no equal sign and answer. Now, I have here an example. Examples of equations. So, the sum of n and 7 is 15. Now, in symbol, it can be written as n plus 7 equals 15. So, another 10 added to the difference of 50 and 20 equals 40. So, this can be written in symbol as open parentheses 50 minus 20 close parentheses plus 10 is equals to 40. Okay, do you understand the examples? Okay, very good. So now, to solve for Joey's age, we will add 9 and 5. So that is 9 plus 5 equals 14 years old. 9 plus 5 equals 14 is composed of expressions 9 plus 5 and 14. So they are joined by an equal sign. That's why it is called an algebraic equation. Now, what is algebraic equation? So, algebraic equation is a combination of algebraic expressions connected by an equal sign. Do you understand? Very good. So after how many years will Joey be 14 years old? Now, we can represent this as 9 plus h equals 14. Now, what have you noticed in the equation? Yes, Cheryl? Okay, that's right. So the equation is composed of number 9 and a variable h, joined by a plus sign in the left side of the equation, while 14 is on the right side of the equation. Also, the expressions are separated by an equal sign. That's right. Here are other examples of equations and algebraic equations. All right, so do you have any questions or clarifications regarding expression and equation? None so far? Okay, very good. Now, we will have a short activity. Now, I will divide the class into two groups. Each group will choose a representative, and the rest of the group members will help to get the correct answer. I will provide a sentence and you will translate it into symbols. Like for the examples I've given earlier. And then the group will receive more points will be a winner. Do you understand? Very good.
So today I will discuss the statistics and probability lesson 1, which is the double bar graph. So a double bar graph is a graphical display of information using two bars besides each other at various heights. So the bar can be arranged vertically or horizontally, the length which represents the frequency. So a double bar graphs compare two sets at once. So here is an example of vertical double bar graphs with its part. So this graph not only shows the average scores of the students of 5 subjects but also represents the average scores of the boys and the girls separately. So the following are the parts of a double bar graph, which is the title, the bars, the horizontal axis or x-axis, the vertical axis or the y-axis, and lastly the legend or K. First is the title. So the title of a double bar graph provides a general overview to the learner of what is being measured and compared. It also helps the learners identify what they are about to look at. Next will be the bars. So bar graphs shows information with bars or rectangles which may be vertical or horizontal. So in this, the length of the bar represents the frequency, which means that longer or taller bars show greater numbers than shorter ones do. Third one is the horizontal axis or the x-axis. So the horizontal axis of a double bar graph shows the categories being compared. So it runs left to right. So next will be vertical axis or y-axis. So the vertical axis represents the scale. So a scale is a set of numbers that represents the data organized into equal intervals. So always remember that in most bar graphs like the one above, which is the y-axis, runs vertically up and down. Typically, the labels of the vertical axis are numbers for the amount of the items being measured. And lastly, which is the legend or K. So a double bar graph also includes a legend or K. So the K for a double bar graph represents the group being compared with two separate colors, while on the other hand, the legend tells us what each other bar represents. So now, let us now construct a double bar graph using the data in the lesson opener. So here are the following steps in constructing double bar graph. First, write the title at the top center. Second, draw the horizontal and vertical axis. Third, write the levels for both axes. And fourth, draw the double bars. So the bars for the same group being compared must be beside each other but of different colors. So the number of the bar corresponds to the number of things being compared. So the height or length of the bars must also correspond to the value of the things they represent. And lastly, which is the number 5. So make the legend or K. So let us look into this picture. So the favorite sports of the year. So in here, the double bar graph may be interpreted as follows. So the double bar graph above represents the favorite sports of first year students. So the K tells us that the black color bars represent the number of male students, while the gray ones represent the number of female students who like to a given sport. So at a glance, we can clearly see the most female students like volleyball, while most male students like basketball. So also the sport which is less liked by male students is volleyball, while that of female student is football. So that would be the end of my presentation, which is the double bar graph. Thank you for listening.
Okay, so once again, good morning. I am Jezreel and I am going to continue the lesson 2, which is all about the line graph. So when we say line graph, or the line chart is a graphical presentation of data with set of points connected by straight lines, which shows how something changes over time. So there are two kinds of graph, namely the single line graph and the second one is the double line graphs. Remember that we're going to use the single line graph if we just only have have to graph temperature levels over a week-long period. And when we say a double line graph, if there are two or more categories that are being compared over time intervals. So, in the graph or in the chart, the graph represents the change in the temperature in degrees Celsius in Himamaylan city over 6-day period. So there are 7 parts in the line graph. The first one is the title. So the title provides the keywords to tell what is the graph is all about, and it also helps the readers what they're about to look at. So in the graph, what is the title? Yes, very good. The title in the graph is temperature in Himamaylan city. So the second one is the scale. It shows the units on the vertical axis or the y-axis. So the numbers used in the scale must be equal intervals. So from the graph above, you can see that the scale ranges from 0 to 40. And since it is stated that it must be equal, so their their equal interval is 10 degrees Celsius between two temperature. And the third one is the point. So it represents the amount of something being measured. So in the graph, the points there are represents the temperature in Himamaylan city over how many period of days. So we have 6 days. Very good. So the fourth one is the line. So it connects the data point. This helps us clearly visualize the amount increase or decrease in the amount of something being measured. So remember, when the line goes up, that means there is an increase of the amount of something. Otherwise, when the line goes down, that means the amount of something increases. However, if the moves constant direction, that means the change in value between two consecutive data points. The fifth one is the label. So this helps us identify what kind of data is shown in the vertical and horizontal axis. And in the sixth one is horizontal axis. It is also called as independent axis because its values do not depend on something. So in the graph, just what I asked earlier, the horizontal axis represents the days which the temperature in Himamaylan city are monitored. And the seventh one and the last one is vertical axis. It is also called as dependent axis because its value depends on those of horizontal axis. So in the graph, the vertical axis represents their amount of temperature measured in degrees Celsius. So let's proceed in making double line graph using the given data in the lesson opener. So take a look at this. So there are 5 steps in creating a double line graph. So the step 1 is first create a table. Draw the vertical axis on the top of the page. Place an appropriate title that briefly describes the data. Step 2. Label the horizontal and vertical axis. Make sure that the vertical and horizontal lines are equally spaced depending on the amount of something being measured. It does not necessarily mean that you should always start from the scale of 0. Step 3. Plot the data points. So this time, you may have multiple sets of points depending on how many items are being compared. And the step 4 is to connect the data points using the straight lines. Make sure to connect the points that work on the same item only. And the step 5 is create a K or legend if you are comparing multiple items. So the graph shows the grades in math in Naomi and Matthew for the school year 2018-2019. So the legend there are the diamonds and the square where the diamonds represents on Matthew's grades while the square one represents on Naomi's grades. So based on the graph, we can say that Both Matthew and Naomi acquired their highest grade and during the second quarter of the school year 2018-2019. So, are we clear? Do you have any questions so far? Alright, so that's all for lesson 2.
Hi everyone, in this lesson we will be learning on how to create a pie graph. So, what is pie graph? Pie graph are used to show the percent of the quantity in each of the several categories. It can also be used to easily visualize a ratio. So basically, a pie graph is a visualization of a ratio. To create the pie graph, let us consider some steps here. Pie graph is also called a circle graph because the shape is just like a circle. So let's have an example. Here, there are 24 hours in a day, and you spend 8 hours at school, 8 hours in sleeping, and 2 hours studying, 2 hours in playing, and 4 hours watching TV. So let us create a pie graph out of this given. So here is our given. Now let us analyze. So there are 24 hours a day. So here we have 8 hours in school. And so the first step is to get the percentage of each given. This. So to get this percentage, we have 8 divided by the 24 hours times 100%. So the formula that we are using when we are going to find the percentage is the value divided by the total value times 100%. So here is the example. The value is the 8 hours in school. The total value is 24 here because we have 24 hours a day times 100% is 33.3%. And here same times 100% is equal to 33.3%. Now 2 hours divided by 24 hours times 100% is equal to 8. Same here. Is equal to 8. Now for here, 4 divided by 24 hours 24 hours times 100% is equal to 17%. So after getting the percentage of each given, let us now create the pie graph or the circle graph. So to create the pie graph, let us make or create a circle first. So let us now divide the circle for the 33% let's have the title first. My day. Okay, for the first given is 33.3%. Let's now divide here. 33.3% for the hours of hours in school. That's right. Now let's have the another 33.3% of hours in sleeping. So let's have the 8%. 8% of studying. This is studying. And another 8%. 8% of playing. And the rest, the left, is the 17% of what? 17% of watching TV. So here now our final pie graph. So now let's proceed to lesson 4, which is all about experimental and theoretical probability. So first, let us define what is probability. Probability is the measure of how likely the event will occur. The likelihood of an event to occur can be presented using the probability line. So probability is always between 0 and 1. 0 probability indicates that the event is impossible to occur, while perfect probability implies that the event is certain to happen. Events with less than probability or 50% chance are said to be unlikely to happen. On the other hand, events with greater than probability or 50% chance are likely to happen. As we go along with our discussion, we will encounter these following terms. The first is experiment or trial is any procedure that can be repeatedly done and has a well-defined set of possible results. Event refers to one or more results or outcomes of the experiment. Outcome could be simply understood as the result of our experiment. Sample space is the set of all the possible results of the experiment, and the individual outcome is termed as the sample point. So now let's proceed to experimental versus theoretical probability. So when we say experimental probability, this is one that we're most familiar with, no? And the experimental probability is the chance of something that to happen based on the actual result or experiment. On the other hand, theoretical probability, we don't actually conduct an experiment here. An example of these are roll a die or conduct a survey. So this can be better understood through the given examples below. So example 1, Ivan flipped a fair coin 10 times and got 4 heads. What is the experimental probability the coin landing on heads? So here, Ivan flipped a fair coin 10 times and got 4 heads. So we have here, we can find the experimental probability this way, the solution. Probability heads is equal to number of times event occurs divided by the total number of trials. So since there were 4 flips that shows head and 4 and out of 10 flips attempted, so this could be the equation. Probability heads is equal to 4 divided by 10, because 4 is because Ivan got 4 heads out of 10 flips. So here, or we have the 2 divided by 5, or 40%. So how did we get the 40%? So here, 4 divided by 10 times 100% is equal to 40%. Now, let's proceed to example number 2. Suppose you are going to flip a coin once. What is the theoretical probability of the coin landing on head? So here is the solution. Because a coin has 2 faces, we all know that the coin has 2 faces, the head and the tail. So the solution or the equation here is probability heads is equal to number of times event occurs divided by the total number of trials. So since there is only 1 head out of the 2 faces, so we have the equation is probability heads is equal to 1/2 or 50%, because we cannot predict the result in just 1 flip. So it is maybe 50% head or 50% tails. So that is the theoretical probability. So here, in experimental probability, the probability of an event is based upon the actual outcome of the experiment, while in theoretical probability, there's no need to conduct an actual experiment to determine how likely the event will have. So here, let's have the example number 3. Carlos spun a color wheel which was divided into 6 equal parts, for 25 times. The result of the experiment are presented in the table below. So here, the outcomes are red, blue, these are the colors: red, blue, yellow, orange, green, violet. And the frequency 6 for red, the frequency of color red is 6, the frequency of color blue is 3, yellow 5, orange 2, green 2, violet 2, and a total of 25. So based on the given results, what is the probability of spinning a green? So we all know that the frequency of the green color is 2. So here is the solution or the equation. Probability green is equal to 2, because here we have 2 the frequency, and 25 is the times that we spin the wheel. So why, I know you ask, why is it 8% here? So 2 divided by 25 times 100% is 8%. So based on the given result, what is the probability of spinning a primary color? And we all know that the primary colors are color blue, red, and yellow. So the spinning of primary colors occurred 14 times out of 25, because here, if we go back here, for red we have 6, blue we have 3, and we have, for yellow we have 5. So there are 14 14 14 primary colors, frequency of the primary colors, and there are 25 times to flip. So 14 divided by 25 times 100% is 56%. So what is the theoretical probability? So let's have here the this is the in the primary color, the 56% is the experimental probability. So let's have an example of theoretical probability of spinning a violet. So based on the given color wheel, there are 6 colors and one of these is violet. So probability violet is equal to 1/6 or 17%.